Assalamu alaikum. So as you know that we have an exam coming up very soon, so for that we are sending a few, creating a few notes, as well as trying to understand how to solve the questions, and also understanding what are the basic formulas for each of the topics, and how do we understand them in a bit more detail. This is all designed to help you out for your exams. So of course, if you have any questions, we have a group coming up very soon, so you can ask any questions you have in that. And if you want to, or if you wish to have, like, let's say a face-to-face discussion. Okay, so we actually have renovation going on, so there's a lot of sound going, but please don't mind it. But the main reason behind is that we want to help each and every one of the student for this class, and which is why we have come up with this idea to basically have a video, giving you the information or details how to solve the equations, and a discussion session where we can collaborate and discuss how to solve the questions and problems. So inshallah, may Allah make it easy for us. So this is just a trial run how we're going to do it. If you have any suggestions for the video, or any suggestions how we can improve the quality of the video, or what else we can add, or any topics that you want to basically have the the video for, just let us know, and inshallah we will do our best to make it. So just to give you an idea, so the first topic that we're going to discuss is of course differentiation, and keeping the video very short, we're just going to discuss only a few formulas, and then we're going to skip to the next video. So for this one, let's just go ahead. What is differentiation, right? So in a simple way, differentiation is a way to understand, like we see in the later topics, to get a better idea on how to find, let's say if there's a curve on the graph, right? So what is the slope of the curve on the graph itself? So that's where differentiation really helps us to understand, okay, what is the position of that particular curve? Is it giving us a positive curve or a negative curve? But for now, in simple terms, how do we solve it? Well, there are formulas that we need to follow. So let's look at just the first one for now. So this right here is a symbol for differentiation. Of course, you don't need to write it, but I'm writing it over here just for you to understand it. In the exam, you can just go ahead and solve for the equation, and that would be enough. So I'm just going to show you example how you can do that. Okay, so the first formula says that if you differentiate any constant, so C stands for constant, and constant can be any other number except for the variable, right? So the C can be 8, can be 10. So C can basically be either 8, can be 10, or any amount of number, right? But not X, not the variable itself. Yeah, we're gonna have a lot of sound in this video, but hopefully please don't mind it. From next video onwards, we're gonna make it some better changes in it. So any number itself. So if we differentiate that number in terms of X, if you see at the bottom, whatever the value or the variable here is, right, we're doing the differentiation in terms of that particular value or variable. So we're doing the differentiation in terms of X. There's no X over here. It's either a number, right? So we cannot differentiate any of that number. So it will usually just be 0. Why? If you ask, well, the main concept is that there is, let's say, a hidden 1 in front of it, right? 1 times C is nothing but C itself, right? Any number multiplied by 1 will just give the same number, right? So that 1, where do we get it from? Is basically that we have a hidden X over here, and that X 1 times C, right? So there is no X in between. So okay, so it seems that the video got cut in between, but what I meant from this section was this one right here. What I meant was, let's just do it on a fresh page right here. Keep it here. So any when you try to differentiate d over dx, right, of any constant, right, why is it always equal to 0? Well, the concept is because there's a hidden 1 in front of it, right? So 1 times C, right? And how do we know that there's a hidden 1 in front? Because any number multiplied by 1, whether it be 8 or 1 times x itself, right, is always going to give the same value, right? So it's just going to be 8, or in this case just x. So what happens is we just expanded it 1 times c. And why did we write 1 over here? Because again, if you remember, any number raised to the power of 0, I'm just going to talk in the video again, is always equal to 1, right? Test this in your calculator, it will always come to 1. Even if there's a number raised to the power 0, always equal to 1. So that's how we have a hidden 1. And of course, this is not going to come in the exam, but just an understanding how this is always equal to 0. So let's say if there is a hidden 1, right? So this 1 we can replace it with x equal to 0 times the c of constant. This, right, is same thing what we wrote over here. It's exactly what c, because x of 0 is nothing but 1. 1 times c is what? Just c, right? So we expand it in a way of this format. And now if we try to differentiate, look what happens. What is the power rule again? PR. In the video I will explain again. But what happens over here, that any number, let's say when we try to differentiate when there's a power involved, right, the power will be times the variable and the power will be subtracted by 1. So in this case, what happens is that 0 comes down, right? So 0 times x, and which is raised to 0 minus 1. And of course, we can solve for this section here, but we know any number multiplied by 0 is always 0. So this all becomes 0, right? And of course, this is in, let's put this in bracket because we also multiply by the constant, right? So now when this equals to 0, we are multiplying it again by the constant. And again, any number multiplied by 0 will always give us 0. Which is why when we try to differentiate in terms of x for any constant, it will always give us a 0, no matter what happens, because of the hidden 0 that comes down and gives us the value of 0, then which we multiply by c. It sounds confusing, but don't mind. It's gonna be very easy in the later videos, inshallah. So let's say, for example, let's give you an example, right? Example, I want to differentiate d in terms of x for number 20, right? But since there's no x over here, so how do we solve for this? We say that this one is equal to 0. That's it. So this would be your answer. Again, dy by dx, any other number, let's say 17, right? Now 17 and all these are constant. They are not changing. The meaning of constant is that they remain the same. But variable, on the other hand, is not constant. It will change, right? The value is not the same. So which is why for this case again 0. But what happens if we have a variable and it is raised to the power of n? Now this is where the power rule comes in. So this is also known as the power rule, or the PR, you can say, right? How do we solve it? Well, the formula says that you need to differentiate it. When you differentiate any variable raised to the power n, it will be basically n multiplied by, right? The n at the power will actually come down and be multiplied, right? It will come down to multiply by that variable. And at the top, there has to be some changes with the power itself, because if there is no change, meaning we're doing something wrong. So what is the change? Well, the formula says that there has to be -1. We need to reduce the value of the power by 1. Let's take an example. We have a, let's say, x raised to the power 2, right? And we want to differentiate it. So when we differentiate it, d over dx, right, in terms of x, how do we differentiate it? You need to bring that 2 down, which is 2. Then what do? We multiply that with the variable, and the power, which was already 2, we need to subtract it by 1. So in this case, what happens? If we solve it, this becomes just 2x, correct? And that becomes 1. Now there is no need to write x raised to the power 1. We can just write it as 2x, right? Because any variable, let's say a raised to the power 1 or even 17 raised to the power 1 is just the same number itself, which is why we don't need to write 1. Okay, so that's the main reason behind it. Now let's do one more example. Let's take an x raised to the power 7, right? How do we do it? Again, we would differentiate it. Now you don't need to write d over dx every time, so what you can do is just go ahead with the next step, which is directly solve 7 times x, 7 minus 1, which is what? 7x raised to the power 6. Easy. Now what happens if we have x, just x? How do we differentiate this value? Well, you need to remember that there's a hidden 1 on the top, right? So what happens when we differentiate dy over dx for x? Well, that 1 basically goes, there's a hidden 1, right? If you remember from this example, that goes down, times the variable. Yeah, Paul, again, once more, very sorry for the music, not the music, but the sound, they're working. So inshallah, next video, we'll make sure that that doesn't happen. Okay, now there's 1 at the top, right? So that has to be subtracted because the rule says that you have to subtract it by 1. So when we subtract this 1, now something happens over here. What is that? Any number base or any variable raised to power 0, or let's say even a number, let's say 2 raised to the power 0, is basically always equal to 1. Now to show you proof, let's get my calculator here. And let's take the example 2, right? There we go. Now this 2, I'm gonna raise it to the power of 0, right? Not sure if you can see it, but the answer will always come as 1. Any number that you put raised to the power of 0, always equal to 1. Same with the variables, right? So what happens when I subtract over here? This becomes 1 times x raised to the power 0, which is nothing but 1 times 1. And what this means is that the answer will just be 1. So this basically is very important for us to understand in solving the questions in future. Okay, so this is just a gist of the main the video idea that we're trying to do, and inshallah every day we're going to post up new questions as well and open room for discussions so that you guys can collaborate together, and hope this will be helpful for each one of you to prepare for your examinations, inshallah. Jazakallahu khair.